In this video, we're looking at a one-dimensional kinematics problem where acceleration is not constant. So that means those famous kinematics equations that we derived for constant acceleration, those are no good for this problem. We're going to have to use calculus. So we're told that an object is moving with this given velocity function of 3 meters per second minus 1/2 t squared meters per second cubed. Now those units can be a little distracting, but those are just there to make sure that v comes out in meters per second. So the first term is straightforward enough. It's 3 meters per second. That has units of meters per second. The second term is a function of t, and because I have a t squared in there, that carries 2 factors of seconds. So the units for this entire term have to be written as meters per second cubed, so that 2 factors of seconds will cancel and give me units of meters per second. Now in practice, you don't have to write these units when you start doing the calculus. So in part A, we're asked to find the acceleration at t equals 2 seconds. So it's a lot easier to just drop the units at this point, and I trust that my units are correct to make v come out in meters per second. So my velocity function is 3 minus 1/2 t squared. The acceleration is given by the time derivative of the velocity, so I need v prime of t. And when I differentiate the constant, I get 0. And when I differentiate the 1/2 t squared, I have to use the power rule. So I bring down a factor of 2 in front and subtract 1 from the original exponent, giving me a t to the 1, or just t. And my acceleration function turns out to be, in general, a negative t. Now, of course, that will have to have the correct units attached to it to make it come out in meters per second squared. But in practice, we just trust that things are going to work at this point. So now I want to plug in t equals 2 seconds. And when I replace t with 2, I simply get an acceleration of negative 2 meters per second squared. In part B, we're asked to find the displacement on the time interval 0 to 2 seconds. So we have to remember that the displacement is given by the integral from the initial time to the final time of the velocity function dt, so v of t dt. And so we plug into this. My initial time is 0, my final time is 2. My velocity function is 3 minus 1/2 t squared. So I have to get the antiderivative of that integrand. And when I integrate the 3, I get a 3t. And when I integrate the 1/2 t squared, I have to use the power rule backwards now. So I add 1 to the exponent and divide by the resulting number. So that gives me a 1/3 out in front and a t cubed. And then we're evaluating this from t equals 0 to t equals 2. Now notice that when I plug in the lower limit here, I get a 0 minus 0. So that doesn't contribute anything. I can just cross it out right there before I evaluate it. Plugging in the upper limit, I get a 3 times 2. And then this second term has a 1/6 out in front, just multiplying those fractions, times t cubed. 2 cubed is 8. Now we just have to clean things up a little. I have a 6 minus an 8 over 6, which is 4 over 3. 6 can be written as 18 over 3, so 18 minus 4 gives me a 14/3. And that's a fine answer, but in a physics class, I normally just round things off to 3 sig figs. And this gives me a displacement of 4.67 meters, and we're done. If you enjoyed this video, or at least found it useful, check out another one by clicking one of the links on the left, or click the Zach's Lab logo on the right to explore dozens of physics and math playlists. As always, you can leave your questions, comments, and requests in the comments section below, and I'll get back to you within 24 hours. Thanks for watching Zach's Lab, and best of luck on your math and physics journey.